common examination question relating to composite functions involves taking two functions that have particular domains and then finding the composition of those two functions as well as the domain that defines the composite function. So in our example, we have got f and g, which are functions defined over their maximal domains. f1 has a domain of d1, where f of x is log e of x minus 3, and g is a function that has a domain of d2, and gx is defined as x squared minus 1. So part A is we have to find d1 and d2. So there is a command in the calculator which can find maximal domains for us. Unfortunately, you cannot access it from any menus, so we have to go to the catalog, the book button, as you can see. The easiest way to get to the domain function is to press the book first, then press E, and then press up a few times until you get to the domain command. Once you get there, you press enter, and then we need to type in log e x minus 3. Now, there is a quicker way to type log e, and that is the ln command. So you get ln by going control and e to the x, which gets us ln. Then you get x minus 3, close the bracket, comma x. Hit enter, and we get a domain of x is greater than 3 and less than infinity. When you write that on your paper, you can say x is an element of 3, infinity, surrounded by round brackets. Likewise, we'll want to look at the domain of g of x. So let's do the same. When you press the catalog key now, you'll see that the calculator has remembered where you were last, and you were on domain. So fortunately, you can just press the catalog key, then press enter. Now let's type in the second function, which is x squared minus 1, comma x after that. So domain x squared minus 1 for x, and as we expected, the domain of that parabola is all real numbers. So when you write this on your piece of paper, you would say x element of R. Our next question, which is part B, asks us to find the rule for h of x, where h of x is f of g of x. So h of x is the composite function where f is composed with g. So before we proceed, it might be a good idea to actually define our f of x and g of x functions in our calculator. So you can press f, open bracket, x, close bracket, and use the assign command, which is control and the template key. And we can type in ln of x minus 3. That defines fx in the calculator's memory. Now let's repeat the same with g of x. G of x is assigned to x squared minus 1. And we can hit enter there as well. So we've got f of x and gx defined in the calculator's memory. Of course, we could have done this at the start of the problem and then repeated our domain calculations with f of x and g of x rather than typing them in individually like I did before. So we want to find the rule for h. So the rule for h just means that we want h of x equals something. We're not worried about the domain just as yet. So the calculator is very good at subbing in functions into other functions. So all we have to do is press var, and then f is already there. And the good news is the calculator knows that f is a function, so it already puts a bracket there because it's expecting an input into the function. And then we also want g inside there. So press var again, press g, press x, and hit enter, and the calculator has subbed in g of x into f of x to give us log e of x squared minus 4. So when you write this on your piece of paper, you would write h of x equals log e of x squared minus 4, and that completes part B. The next part is part C, where we're looking at the domain of h. Now, when you look at the domain of h, which is a composite function, you must make sure that you understand the rules that apply when a composite function exists. And in this particular case, in order for f of g of x to exist, the range of the inside function, which is g of x, must be a subset of or equal to the domain of the outside function, which is f of x. So what we might do is quickly have a look at the graphs of both f of x and of g of x and see what the domain and range of each of those is. So to quickly get a graph screen, we can press Control I, and then we can create a graph screen that way. So to graph f of x, I can just go to var again, press F, press X, close the bracket, and that right there is the graph of f of x, which was our log e of x minus 3. As we saw before in the previous line, in the previous page, sorry, the domain of our log e function was x greater than 3, and that is evident in this graph over here. What we can do is then put the graph of g of x by pressing tab, then pressing var, going down to g, x, close the bracket, and we've got g of x there as well. So let's think about what we might want to do with this information here, is we can create a table of domain and range for both f and g. So when you look at these two graphs over here, the domain of f of x is 3 to infinity, with 3 not included. The domain of g of x is all real values, or r. The range of f of x, this graph, which is a log graph, goes from negative infinity all the way to positive infinity. So the range of this graph is all real numbers. Furthermore, the range of g of x is simply -1 from the minimum turning point all the way up to infinity. So we can see the domain and range of f and g in the table presented to you. What we need now is that we need the range of g of x. Remember, g of x is the parabola. We need the range of g of x to be a subset of or equal to the domain of the log graph, which is the blue graph here. In order for the range of the parabola to be equal to the domain of the log graph, we need to understand that the log graph's domain is from 3 to infinity. So what that means is, if you try and visualize it, I'm going to put a straight line of 3 over here. What this means is that all the y values on the parabola must be sitting above this black line, which is the graph of f3, which is y equals 3. So the parabola's outputs, aka its y values, must be above 3 or greater than 3 in order for those outputs to go into the input of the log graph. So what we might do back on the calculator page is solve an inequality. And that inequality is menu, algebra, solve. That inequality would be the function g of x. So g of x. We want to solve that function greater than 3 for x. And you press enter, and we get this particular solution, which tells us that x is less than -2 or x is greater than 2. We can verify that by finding the intersection of the black graph and the red graph. So menu, analyze, intersection. The graph, we want to intersect the graph of f3 and the graph of f2. The lower bound, you can place this anywhere to the left of the intersection point, upper bound anywhere to the right. As you can see, there's an intersection at x equals -2. Repeating the procedure for the other point, graph f3, graph f2, left, right, 2, 3. So as you can see, that the parabola will have a range of greater than 3 when x is less than -2 or x is greater than 2, as shown in the equation over here. And therefore, in order for f of g of x to exist, which is the domain of h, the domain of H is going to be either negative infinity to negative 2, both with round brackets, union 2 comma infinity with round brackets, or a more compact way of saying this is all real numbers excluding negative 2 comma 2 with square brackets on them.